Hi guys, before we start with our math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. For today, we're going to talk about polynomial functions. So in this lesson, we're going to have now the definition of polynomials, when to say that a specific expression is polynomial, what is a polynomial function, and how to evaluate polynomial functions. So that's what we are going to talk about for today. So for my students, for your reference, you can check on your books from page 73 to 82. So before we start, I would like you to watch this video and listen attentively, because you are going to have a review about polynomials with this video.
What's a polynomial? It's the sum of one or more terms. X squared plus 3x minus 4, with no division and no fractions. What's a polynomial term? It can be a number like 4, can be a variable like x, a number and a variable multiplied together, 3x. With no addition and no subtraction, and with no negative exponents, that is a polynomial term. What's a monomial? It's a polynomial with one term. 2xy squared, one term, a monomial. What's a binomial? It's a polynomial with two terms. 2x plus 4, two terms, a binomial. What's a trinomial? It's a polynomial with three terms. X squared plus 5x plus 6, three terms, a trinomial. What's the degree of a term? The degree of a term is the exponent of the variable. X squared degree 2, 5x degree 1, 6 degree 0. What's the order? Put the terms in order from the highest degree to the lowest. X squared degree 2 first, 5x degree 1x, 6 degree 0 is last. That's a polynomial. That's a polynomial.
Alright, so in this video, you are able to have a review about polynomials and when do we say that a specific expression or equation is a polynomial or not. So in that video as well, you're able to review the classifications of polynomial according to the number of terms. We have monomial, binomial, trinomial, and so on and so forth. Then for the degree, okay, so we can identify the degree of the polynomial according to the highest exponent among the terms. Now let's proceed to polynomial functions. What are polynomial functions? So it's actually a functional relationship between quantities that can be described by an equation where y equals a polynomial expression in x. So what do you mean by this? So it's the relationship between quantities. Let's say the two quantities are y equals x. In some other books, it is written as f of x equals x, wherein y here, or the whole polynomial function, is dependent to the value of x. So what do we mean by that? Y here is what we call independent. Y here rather is what we call dependent, and x is what we call independent. Whatever is the value of x affects the whole value of the polynomial function. So let's say, for example, if there x is a value of x, or let's say we have this example, f of x equals x plus 2, wherein we have the value of x, which is 2. This one is what we call the independent. For you to be able to solve that, you need to substitute. F of 2 is equal to 2 plus 2. Therefore, the value of the whole polynomial function after evaluating is 4. So as you can see, the value of x, or the variable, has a direct effect to the value of y. So that's the relationship between the two quantities of a polynomial function. Alright, so I hope you understand that. Next, let's have the different types of polynomial functions according to the degree. Okay, so let's start first with linear function. when we say linear function, linear, you have to put in your mind that there must be a term within the expression with 1 as the highest exponent. Okay, so example, a first degree polynomial function defined by f of x equals mx plus b. So wherein m and b are constants and m must not be equal to 0. Why is not equal to 0? Because if it is equal to 0, this variable will also become 0. So how are we going to say that this is linear? As you can see, the exponent or the degree of the term is 1, while this one is constant. Okay, so that's why we call it linear function. Among the terms, you must see a term with the highest degree of 1. Okay, so that's what we mean when we say linear function. Next, we have quadratic function. A second degree polynomial function defined by f of x equals ax squared plus bx plus c, where a, b, and c are real constants and a is not equal to 0. So in your grade 9 as well, you are able to talk about a whole chapter about quadratic equations and quadratic functions. So what do you mean by quadratic function? It is a polynomial function as well, wherein the highest possible exponent is 2. So among the three terms, which has the exponent of 2? The first term. So in this case, we can say that this one is quadratic function because as you can see, the exponent or the highest exponent among the terms or the degree is 2. So that's why we call it quadratic. So remember, when we say quadratic, 2. The highest degree of the polynomial function is 2. Next, we have polynomial function. This is the general term for all the classifications of polynomial functions according to the degree. So polynomial function, a function defined by f of x equals a sub n x raised to the power of n plus n sub n minus 1 x raised to the power of n minus 1 plus a sub n minus 2 x raised to the power of n minus 2 plus and so on and so forth plus a sub 1 x plus a sub 0, where a sub 0, a sub 1, and so on, a sub n minus 1, a sub n are real numbers, wherein a sub n is not equal to 0 and n is non-negative integer. What do we mean by this? So as you can see, when we say polynomial functions, you can actually arrange that. Based on the video a while back, you can arrange it from the highest degree to the lowest. So that's the thing. But take note of this, if the terms are not arranged from the highest degree or exponent up to the lowest, it is still a polynomial function. It's just that it's not arranged. Okay? Now, when arranged in descending order, the leading or the first non-zero coefficient is a sub n and is called the leading coefficient, and the degree of the function is n. So let's say, for example, we have the function f of x equals, and it is arranged in descending order, 2x squared plus 2x plus 4. Okay, so this is a quadratic. And then this one is what we call the leading term. Okay, what do we mean by leading term? It is the term with the highest degree or exponent. Again, when we say leading term, it is the term with the highest degree or exponent. Okay? Now, in the leading term, we have what we call the leading coefficient. Leading coefficient is also the numerical coefficient. It is the number which is attached with the variable with the highest degree. So, in this case, 2 is what we call the leading coefficient or LC. So, the whole thing is, this one is the leading term and the leading coefficient is 2. You have to take note of that. 2 is the numerical coefficient which is attached to the variable or literal coefficient with the highest degree or exponent. So that's what we mean by that. Next. So to better understand, let's run down the different types of polynomial functions. So let's say we have the constant. When we say constant, guys, the degree is 0. Degree is 0. Why? Example, p of x equals 7. So, according to the video a while ago, if you're going to ask me, teacher, why the examples a while back has letters or have letters? Okay, so it's because they are polynomial. They are polynomials. It means we have variable. There must be a variable within the expression if that's the case. But in this case, we only have 7, and this one is what we call constant function. Where's the letter? The letter is there. It's just that the degree of a constant is 0. So you have to take note of this. The constant function has 0 degree because it can be written as p of x equals cx raised to the power of 0. So this can be written as 7x raised to the power of 0. How come it became only 7? So it became only 7 because if we're going to apply the zero law of exponent, when you raise a specific term to 0, the answer is always 1. A specific number, variable, when you raise it to 0, the answer is always 1. That is what we call the zero law of exponent. So therefore, if x raised to the 0 power is 1, we can actually rewrite this as 7 times 1, and 7 times 1 is just simply 7. So take note, a constant function, when if you are going to be asked if what is the degree of a constant function, it is 0. It is 0. Next, we have the linear. Of course, when we say linear in the previous slide, we are able to define what is linear. The highest exponent is 1. Example, p of x equals 3x minus 2. Look at the term with the highest exponent. Is it 3x or 2? Or negative 2 rather. So 3x has an exponent of 1 and that is the highest among the term. So therefore, 3x is what we call the leading term and 3 is what we call the leading coefficient. So take note of that. That's what we mean by linear. Next, we have quadratic. When we say quadratic, the highest exponent is 2. The highest exponent is 2. So we have p of x now equals 2x squared minus 3x minus 5. So if it is not arranged, it's also okay for as long as you're able to identify if which term has the highest exponent. In this case, we have 2x squared. Okay, so quadratic means the degree is 2. The degree of negative 3x is 1 and the degree of negative 5 is 0. That's why just look at the highest degree. So it's 2x squared. So 2x squared is what we call the leading term and 2 is what we call the leading coefficient. Next, we have cubic. When we say cubic, of course, cubic means 3. The highest degree is 3. So we have now p of x equals x cubed plus 2x squared plus 5x minus 3. So among the terms, if the terms are not arranged, just look at the term with the highest exponent. In this case, it's x cubed. So look at this one. The highest exponent is 3. And x cubed is what we call the leading coefficient. And then what is the leading? The whole x cubed is what we call the leading term, while the leading coefficient is the number attached to x cubed, which is 1. You cannot see 1 there because, guys, in algebra, we are not anymore writing 1 as the exponent of the variable or coefficient of the variable. It is understood that there's 1 there. So it is a factor of it. Now, so it's 1. So your leading coefficient is 1 here. Alright, so did you understand that? Now, let's have quartic. When we say quartic, the highest degree is 4. Okay, so example, we have p of x equals 1 half x raised to the power of 4 plus 3x cubed minus 2x squared plus 5x plus 5. So, 1 half x raised to the 4th power is your leading term because it has the highest exponent. And 1 half is what we call the leading coefficient. Teacher, is it okay to have a decimal, fraction, radical, and so on and so forth as a coefficient? Yes, it's okay for as long as it is a real number. There's no problem. When we say real number, these are the numbers with definite values or with values. Now we have quintic. When we say quintic, okay, the highest exponent of course is 5. Okay, so we have p of x equals 10x raised to the 5th power plus 1. Oh, teacher, where are the other degrees? The 4th, 3rd, 2nd, 1st. So guys, this is what we call an incomplete polynomial functions because the other degrees are not there because their values are actually zeros. Now, 10x raised to the 5th power is what we call the leading term because it has the highest exponent of 5. Okay? And then 10 is what we call your leading coefficient. Oh, teacher, how are we going to write it to make it complete? So if you would like to make it complete, it's now p of x equals 10x raised to the 5th power, and then the other terms that are unknown, their values are 0. So therefore, we can say that we have 0x raised to the 4th power plus 0x cubed plus 0x squared plus 0x plus 1. So as you can see, this is now complete. But you're not going to do this one for as long as you're able to identify the terms, and if it is incomplete, there's no problem with that. You need to write all the terms with the 0 values if and only if you are dividing. You are dividing the polynomials. Okay, so that's the time that you're going to do it. So please take note of the conditions of becoming constant, linear, quadratic, cubic, quartic, quintic, and identifying the leading term and the leading coefficients, and how to arrange it from the highest degree up to the lowest degree. So let's have the first example. Decide whether each function is polynomial in one variable. Guys, we are going to talk about only polynomials in one, or polynomial functions in one variable. Okay, so let's have letter A. Just say yes or no. P of x equals 31x squared plus 12x raised to the 4th power minus 15x cubed plus 3x plus 5. So, look at now the term with the highest exponent. So as you can see, the terms are not arranged from the highest degree up to the lowest. So but still we can arrange this one. So as you can see, the term with the highest exponent is 12x raised to the 4th power, and it is actually a polynomial because there's no, just look at the variables. According to the video a while ago, there are conditions to consider, so for us to be able to say that if a specific expression is polynomial or not. So the terms have no problem, so therefore we can say that this one is a polynomial function. So if the variables have negative exponents, and if the variables are in the denominator, therefore they are not. Okay, so let's have letter B. F of x equals 2 plus 5xy raised to the 6th power minus 8x cubed. So in this case, we are only talking about one variable, but there are two variables here, x and y. Therefore, this is not a polynomial function because of that. Now let's have letter C. H of x equals 8x raised to the 5th power minus 4x cubed plus 1 over x. This is not a polynomial function because of this. There must be no denominator, which is a variable. So that's why this is not a polynomial function. So take note of that. Okay? So the first thing is we have two variables, and in the second one, okay, so in the denominator there's a variable that's not allowed. This is what we call rational expression or rational function because, okay, the variable is in the denominator. Now, let's have letter D. G of x equals x raised to the power of negative 7 plus 2x raised to the 6th power minus 4x raised to the 5th power plus x plus 3. So, in this case, this is not a polynomial function because of this term. Because the variable has an exponent of negative 7. And you are not allowed, this is according also to the video, a polynomial must not have a negative exponent, no, in its variable. Alright, so in this case, it has negative 7, therefore this is not a polynomial function. So take note of those things. Just check the variables if they are 2 or more, okay, or if the variable is in the denominator, or if the variable has an exponent of negative, so therefore those are not examples of polynomial functions in one variable. Now let's have letter E. Q of x equals 6x minus square root of 5 plus pi x squared. So in this case, in the previous slides, okay, so I have mentioned that we do not care if the coefficients are radicals, okay, fractions, decimals, for as long as they have the definite value and they are real numbers, there's no problem with that. In this case, teacher, how about pi? Pi is a real number as well because it has a definite value of 3.14. Alright, so therefore this is still a polynomial function. Now let's have letter F. F of x equals 1 half x raised to the power of 2, or 1 half x squared plus 2x cubed minus 11x raised to the power of 5. Now in this case, guys, okay, so as you can see, this one is a fraction, but that's not a problem for as long as the variables are correctly written and there's no problem with the variables, it is still a polynomial function. Now let's have letter G. P of x equals 9. This is very easy because as you can see, we have our example a while back with the types of polynomial functions according to the degree. Okay, so 9 is a constant wherein the degree is 0. So that's why this is still a polynomial function. So among all the letters or examples, 3 of them are not polynomial functions because of certain conditions, or they are not able to satisfy the different conditions of becoming a polynomial function. So you have to take note of those things. Okay, thank you. Next, find the degree of each polynomial and arrange it. When you are arranging, you have to take note that you have to arrange from the highest degree up to the lowest degree. Again, you have to arrange from the highest degree up to the lowest degree. Just like this, we have P of x equals 31x squared plus 12x raised to the 4th power minus 15x cubed plus 3x plus 5. So choose the term with the highest exponent, 12x raised to the 4th power. So therefore, this polynomial function is a quartic. So the degree is 4. So if the degree is 4 and we are also being asked to arrange it. So in arranging, you have to take note from the highest degree up to the lowest. So therefore, we can write this as p of x. The highest degree is 12x raised to the fourth power. Then, if when you are arranging as well, please include the signs if it is negative or positive. So minus 15x cubed. So after 4, it's 3. And then plus 31x squared. Then we have 3x plus 5. So therefore, we can see now that this one is a complete polynomial functions because the degrees are there. 4, 3, 2, 1, 0. So it's a complete polynomial function and it's now arranged from the highest degree up to the lowest degree. Now let's have letter B. F of x equals 2 plus 5x raised to the power of 6 minus 8x cubed. So as you can see, this one is an example of incomplete polynomial function. So just look at the term with the highest exponent, which is 5x raised to the 6th power. Therefore, the degree of this is 6. So you can now arrange it in descending order. F of x is equal to 5x raised to the power of 6 minus 8x cubed plus 2. So it is now arranged in descending order from the highest up to the lowest. So we only have the degrees 6, 3, and 0. Okay? Next, let's have letter C. Q of x equals 6x minus square root of 5 plus pi x squared. So the degree of this polynomial, just look at the term with the highest degree, which is pi x squared. So the degree of this is 2, and then you can now arrange it. Q of x is equal to, so the highest degree, pi x squared plus 6x minus square root of 5. This is a complete polynomial function. We have the second degree, the first degree, the 0 degree. Now let's have letter D. F of x is equal to 1/2 x raised to the power of 2 or square plus 2x cubed minus 11x raised to the power of 5. So in this case, just look at the term with the highest exponent. The leading term now is negative 11x raised to the 5th power and the leading coefficient is negative 11. So the degree of this polynomial now is 5. So you can arrange it. F of x is equal to negative 11x raised to the 5th power plus 2x cubed plus 1/2 x squared. So as you can see, this one is an example of incomplete polynomial functions because we only have 5, 5th degree, 3rd degree, and 2nd degree. We don't have the 4th, we don't have the 1st, and the 0 degree. Now let's have the last one. P of x equals 9. What is the degree? The degree is 0. And you don't need to arrange this one because it's already arranged and it has only single term. Okay, so that's how you identify the degree of a polynomial function and also how to arrange it. Remember, when you are arranging it, you have to arrange it in descending order from the highest degree up to the lowest degree. Now, let's proceed evaluating polynomial functions. Guys, what do you mean by evaluating polynomial functions? So when we evaluate in algebra, it means that there exists a specific value of the variable that will give the whole value of the expression. So it means you are going to substitute a value to the algebraic expression for you to be able to get the actual value of the expression. So in this case, we will evaluate polynomial functions using the independent variable or value of the independent variable to actually give the whole value of the expression. So that's what we mean when we say evaluating. So it's different when we say simplifying. So when we say simplifying, you are just shortening the whole expression by applying some algebraic techniques to acquire the final answer. It's different when you are evaluating. You are going to substitute something. Now let's proceed. Guys, there are two methods in evaluating. So the first method is synthetic substitution and the second method is direct substitution. We are going to apply these two methods in the example, and it's up for you to decide if which method do you prefer most. It's up to you now if which method do you prefer most. If you prefer the method 1 or the method 2, there's no problem with that because in your examination I'm not going to ask you to use a specific method. Alright, so if which is easier for you, it's fine, use it. Now let's have example 3. Evaluate P of x equals 2x cubed plus 3x squared plus 4x plus 9, wherein the value of x is equal to 3. Guys, we will be using the first method, which is the synthetic substitution. In using the synthetic substitution, guys, you have certain conditions to satisfy. So the first thing is the polynomial function must be arranged in descending order. Arrange. And then the other one is the polynomial function must be complete. So if it is not complete, I have already taught you a while back on how to complete a polynomial function. You complete it. And then apply, and then remove the coefficients. And then that's the thing. Okay, you can now apply. You can now use the synthetic substitution. Let's analyze this first. So let's inspect if the polynomial function is already arranged in descending order or not. So in this case, we have p of x equals 2x cubed plus 3x squared plus 4x plus 9. So as you can see, the highest is 3, the degree is cubic, and then 2, 1, 0. So it's now arranged in descending order from the highest up to the lowest. But the next question, is it complete? Yes. So 3, 2, 1, 0. So therefore it's complete. The next thing is, remove now the coefficients. Please include the signs. So 2, 3, 4, 9. And then get the value of x, which is 3. Now you can solve for p of 3, which is the value of x. So our divisor, you're going to also use this one in synthetic division in our next lesson. So 3 is your divisor, which is the value of x, and then get all the coefficients, 2, 3, 4, 9, and then equals. So the initial thing that you're going to do is you will bring down the first coefficient, which is 2, and then multiply it to the divisor. So 2 times 3 is 6, then plus 3, 9, and then multiply it again to the divisor. So the process is repetitive, okay? So bring down, multiply, add, bring down, multiply, add until you finish. So 9 times 3 is 27, and then plus 4, or 4 plus 27 is 31. Then 31 times 3 is 93. And then plus 93 plus 9 is 102. So whatever is the last answer in synthetic division, it's what we call the remainder. That's your answer. So p of 3, or the value of the whole polynomial function, is 102. So this is now your final answer. So please be careful in adding or in multiplying and adding so that you will be able to acquire the right answer. Now let's have the second method, or method 2, which is what we call the direct substitution. We must also get 102. Okay, so for direct substitution, just substitute the value, okay, to the whole polynomial function. You don't need to make sure that it is arranged and complete. Now, I would like you to get your calculators and just do it on your calculators, okay, to make your life easier. So, the value of x is 3, p of 3, and then change all the values of x to 3. We have now 2 times 3 cube plus 3 times 3 square plus 4 times 3 plus 9. So as you can see, we are able to substitute all the values. Again, you don't need to inspect if it is arranged and if it is complete. So there's no problem with that. Now, just do it on your calculators, no? 2, and then open parenthesis, 3, close parenthesis, and then in some calculators, you will be seeing the exponent symbol as this, or this. Okay, so click those, or click one of the symbols, if which symbol do you have on your calculators, and then hit the exponent, which is 3, plus 3, open, 3, close, and then raise, 2 square, or 2, plus 4, open, 3, close, plus 9. What is your answer? Can I hear it? Very good. It is also p of 3 rather, equals 102. So as you can see, they are the same. Now, it's up for you to decide now if which method do you prefer most. If which is easier for you, then use it. I'm not going to suggest anything because some of my students before, they prefer synthetic substitution, some they prefer the other method, which is direct substitution. Now let's have example for evaluate p of x equals 2x raised to the 4th power minus 3x squared plus 4x plus 5. Find p of 5 and p of negative 2 using any method. So, to better understand the two methods, the synthetic substitution and direct substitution, we will be using synthetic substitution for p of 5, and we are going to use direct substitution for p of negative 2. Alright? Now, let's start with synthetic substitution, wherein we will find the value of p of 5. So, first thing is, you have to inspect this one if the terms are arranged in descending order, 4, 2, 1, 0. And then the second is, now it's now arranged from the highest up to the lowest. Second is, check if the terms are complete. So, as you can see, we have 4, 2, 1, 0. We don't have the 3. Okay, so therefore, we have to write it. We have to make it complete. P of x is equal to 2x raised to the power of 4. And then the missing, put 0. x cubed. That's how you are going to complete it. Take note. And then minus 3x squared plus 4x plus 5. It's now complete. For synthetic substitution, we need the coefficients 2, 0, negative 3, 4, and 5. Alright, then the next thing is, of course, your divisor is 5. Put it here, 5, and then the coefficients are 2, 0, negative 3, 4, and 5. And then, equal symbol. Bring down 2 times 5 is 10. Plus 0 is 10. Then multiply again. 10 times 5 is 50. Plus negative 3 is 47. 47 times 5 is 235. Plus 4 is 239. Times 5 is 1,195. Plus 5, it's now 1,200. So this is the last here, or the remainder. So therefore, P of 5 is equal to 1,200. So this is now your answer using the synthetic substitution. Now let us solve for P of negative 2. Okay, so using direct substitutions. Here we are going to use direct substitution. Here we used synthetic substitution. So P of negative 2, substitute everything. So 2 times negative 2 raised to the 4th power minus 3 times negative 2 cube plus 4 times negative 2 plus 5. So use the synthetic substitution. What's the answer? Using your calculators. So P of negative 2 is equal to 17. So this is now equal to 17. And that is also your final answer. Okay? So those are the two methods. Now, it is really important also to know the application or real-life application of polynomial functions. So in our previous videos, I'm always telling you this, that for every math concepts that you are going to encounter, okay, with your math teachers, there are applications that you need to take note for you to be able to appreciate it. So it's not just enough that you just be familiar, that you will just familiarize the process or the algebraic techniques. It's also important to know the applications. Now letter A, let's apply it in pharmacy. The polynomial function f of x equals 1/2 x raised to the power of 4 plus 3.45 x cubed minus 96.65 x squared plus 347.7 x can be used in estimating the number of milligrams of ibuprofen in the bloodstream x hours after 400 milligrams of the medicine has been taken. Find the number of milligrams in the bloodstream at x equals 0, 1, 2, and 1, 2, and 3. So it means that when you drink a medicine, it has a specific, it needs specific time frame for it to be effective in your body. So we will now be checking if a 400 milligram ibuprofen medicine travels in your bloodstream. So when we say ibuprofen, it's actually a medicine for migraine or for pains. Okay, now so we will be solving after 0 hour, how many milligrams are there in your bloodstream. So after also 1 hour, after 2 hours, and after 3 hours. So let's start first for m of 0. The best method that I can suggest here is direct substitution, since we are dealing with decimals. Okay, so and you can just simply use your calculators. 1/2 in your calculators, you can just put 0.5 times 0 raised to the 4th power plus 3.45 times 0 cube minus 96.65 times 0 square plus 347.7 times 0. So in this case, just use your calculator and you will be getting 0 milligrams. So therefore, after 1 hour, the effect of the medicine is nothing. Or rather, after 0 hour, the effect of medicine is nothing, because you just drank it. You just drank it. So let's see after 1 hour. So please compute it now. I am going to wait for you in 3, 2, 1. Okay, so when you compute, just hit replay on your calculators and then change all 0 to 1. Okay, so 3, 2, 1. What is the answer? After 1 hour in the bloodstream, there are 255 milligrams. And then after 2 hours, 1, 3, 2, 1, the answer is 344.4 milligrams. And then m of 3, or after 3 hours, how many? We have 306.9 milligrams. So as you can see, the full effect of it is 2 hours, okay? So after 2 hours, the effect is going down. It will not stay forever in your body, okay? So it will just take effect in a specific period. Alright, so the answers are 0 milligrams after 0 hour, 255 milligrams after 1 hour, 344.4 milligrams after 2 hours, and then after 3 hours, it's 306.9 milligrams. Okay? So let's have the next problem. So we're going to apply it in sales. No? So we have the function d of x equals negative 0.015 x raised to the power of 4 plus 0.735 x cubed minus 12.7 x squared plus 60.5 x plus 450 expresses the relationship between the number of CDs sold in 100,000. So if you got the final answer, you have to convert it in 100,000s, and the time x years since 1995. X is equal to 0 in 1995. Find the number of CDs sold in 1999. So you will be counting if we will just be solving one value here, which is the number of CDs sold in 1999. So take note, you have to get first the X that you will be using. So in 1995, it's 0. So therefore, 1996, 1. Then 1997, 2. 1998, 3. 1999 is 4. So therefore, we will be solving d sub 4, or d of 4 rather. So substitute everything. Negative 0.015 times 4 raised to the 4th power plus 0.735 times 4 cube minus 12.7 times 4 square plus 60.5 times 4 plus 450. Now please use your calculator to compute for d of 4. What is the answer? D of 4 is 532. But that's not yet the answer for the problem, because according to the problem, in 100,000. So therefore, the final answer will be 532,000 CDs sold in 1999. Alright? So that's it. So those are some of the applications. So for my students, please don't forget the activity. We will be checking it in our next meeting. Okay, so if you have questions or clarifications, most especially for my students, you know how to contact me. So for those who are not my students, please comment down your questions, and I will be more than willing to ask. I will be more than willing to answer your questions rather. Okay, so thank you so much for being with me in this specific video of a new math lesson. And then please don't forget to hit the subscribe button and the notification bell for more videos. So thank you so much and have a great day.